right, here we go with 8.3, part 2, and this is just an extension of part 1. We're going to use a lot of the same strategies and the same concepts that we learned in 8.3, part 1, but we'll just take it kind of to another area of graphing quadratic functions in the form ax squared plus bx plus c. So let's go ahead and write that down, because we're going to be working with a standard form quadratic. So as a reminder, that means ax squared plus bx plus c. And this can, remember, be either in y equals form, or you'll see it as f of x equals ax squared plus bx plus c. And so when we graph these types of functions, we know that the parabola doesn't start at 0, 0. So the vertex is going to be somewhere else, and it can be up, down, left, or right. But we're actually going to go back a little bit and talk about the a value first. So anytime a quadratic function opens up, meaning the parabola is pointing to the sky, both arrows are pointing to the sky, and the bottom part of the u is at the bottom of the quadratic, that means it opens up only if the a value is positive. And this results in the vertex being a minimum. So anytime you first look at a function, you want to look at the a value. If the a value is positive, we know that it's a parabola that's opening upward, which creates a vertex that is a minimum, because the minimum is going to be at the bottom. And then the opposite of that is the quadratic function opens downward. I'm going to go back up here and actually change this up to the word upward. Well, if it opens downward, then that means the a value is negative. And that is going to result in a vertex being a maximum. Now, none of this is new information. We just want to really hammer this point home, because some of you have been turning in homework assignments where the a value was negative and you had an upward opening parabola, or the a value was positive and you had a downward opening parabola, and that would be incorrect. And so the nice thing is you'll know right away. You'll know right away just by looking at the a value. So if the a value is negative, I see a negative right in front of everything, well, that automatically means that this is a downward opening parabola. Automatically. It also means that the vertex is going to be a maximum. So right away, even before I start plotting points, I already know the vertex is going to be at the very top, and it's it's a downward opening parabola. And the opposite of that is, well, we look at the a value over here. This a value is positive. How do I know it's positive? Because there's no negative sign in front. And so that's going to be an upward opening parabola, and then for the vertex, that is going to create a minimum. So now the vertex is going to be at the very bottom as our parabola opens upward. And so one of the first things we can do is decide, okay, I'm looking at a quadratic function. I know right away if it's opening upward or downward. And then my next step after that is I want to know what the vertex is, where the vertex is, which will also help me know where I can draw the axis of symmetry. And so as we look at these next two examples here, we're not going to graph these. All we're going to do is we're going to figure out, well, where's the vertex? And so as you look at this, my a value on example number 1, that is a positive 5. So if it's a positive number, I already know that this is an upward parabola. And I also know that the vertex is going to be a minimum. Well, now what I want to do is I want to find the value of the vertex. And so we use this over here. We use negative b over 2a. This is what we learned in 8.3 part 1. And so as we work the math here, it's negative. The negative's already here. So my b value here is negative 20. My a value here is 5. So now I have to plug these two numbers into this little expression over here. So what that looks like is this negative sign that is right here is already there, but then I'm still replacing the b with the b value, which is also negative. And I'm putting that all over 2a. Well, if a is 5, and I multiply that by 2, that's going to put me at 10. Well, now I'm at that situation where I have a minus a negative, which really creates a positive. So this turns into positive 20 over 10, which equals 2. Now, what is that 2? This 2 right here is the x value of the vertex. So to find the y value, and it states it over here in the notes, I'm going to take this 2, and I'm going to plug it back in for the x here and here. So let's do that really quick. So it's going to be 5 times 2 squared minus 20 times 2 plus 3. This 2 squared right here is 4. 4 times 5 is 20. This 20 times 2 is 40, but I'm subtracting it. And then I have plus 3. 20 minus 40 is negative 20. Plus 3 is negative 17. So that now is the y value. So my entire vertex had an x value of 2 and then a y value of negative 17. So that is my vertex. That's my minimum value. I knew it was going to be a minimum. This is at the very bottom of this parabola. So if we graphed it, this is the lowest point. Every other point on this parabola goes up. Okay, let's do the same thing for number 2. If it's negative, I have a negative a value. So let's write our a value. We have our a value, that is negative 3. My b value is positive 12. I know this is going to be a downward opening parabola, and I know that the vertex is going to be a maximum value. It's going to be at the very top. So now I'm going to do negative b over 2a. So I have negative b, because the b in this case was positive 12, but this subtraction sign stems from the one that has to be there. And then over 2a, well, this time the a is negative. So now what I have is negative 12 over negative 6. Well, a negative divided by a negative is also a positive, and this also gives me a positive 2. That's just coincidence that the x was 2 here and it was 2 here. That's not always going to be the case. Now let's plug this 2 back in for the x here and the x here to find our y value. So negative 3 times 2 squared plus 12 times 2 minus 7. This 2 squared is 4, but times negative 3 is going to be negative 12. 12 times 2 is 24, and then minus 7. So negative 12 plus 24 is positive 12. Positive 12 minus 7 is going to give me 5. So that's the y value. When x was 2, the y value is 5. That's my vertex at the point 25. And that would be my maximum value at the top of this parabola. Okay. Now in 8.3 part 1, you also did this skill. But now we're just looking at it from the perspective of, okay, I know it has to be either upward or downward, which means the vertex has to be a maximum or minimum, and I want to immediately find where that point is going to be located. Now on the next page, we're going to actually graph the parabolas from a starting equation. Okay, so on number 3, now because we are graphing, the a value and the b value is super important, but one of the first things we actually want to look at is the c value, because the c value already tells us the y-intercept. The c value is always the y-intercept. And that's so helpful to us because that means we already know one point on the line. So this is the point 0, negative 3. So I can go over here on my graph. I'm at 0. I don't go right or left. X is 0. And I go down 1, 2, 3. So I already know that I have one point on my graph. It's not the vertex. It's just a point on the graph. To do my vertex, now I'm going to go through these same steps that we did on the first page. So I'm going to take negative b over 2a. So my a value here is negative 1, because it's just a negative sign in front of the x squared, so there's like an imaginary 1 right here. And then my b value is 4. So with that happening, now I'm doing negative b, so negative b value over 2 times the a value, like that. So the 4 goes here, the negative 1 goes there. And now let's calculate this. Well, this turns into negative 4 over negative 2, which equals 2. Hey, there's that 2 again. Again, pure coincidence. Don't assume they're all going to be 2. And now I have to take this 2, this is the x, so I plug it in for the x here, I plug it in for the x here, and I solve for the y. So it's going to be negative 2 squared, like that, plus 4 times 2, minus 3. And remember, this is to give us the y value of our vertex. So 2 squared is 4, but there's a negative sign in front of it, so that's negative 4. 4 times 2 is 8, so plus 8, and then minus 3. Negative 4 plus 8 minus 3, that's going to give me a positive 1. So my vertex is at the point 2, 1. Now we already knew that because my original a value was negative, this is a downward opening parabola. So as I plot this point at 2, 1, so I go right 2, up 1, okay, that's my vertex. So I know I have to come up through the y-intercept, through the vertex, and down the other way. Well, to help us find one more point, what we do is we draw our axis of symmetry right through the vertex. And I know that this point right here, which was 2 to the left of the line of symmetry, has to have a partner point 2 spots to the right. And so there's my third point that I need, and now I can just sketch my parabola like so. You were using a lot of these same skills in 8.3 part 1. We're just perfecting them now in 8.3 part 2. And I just did all these same steps over here, and we're going to do those again for number 4. Now, what is unique about number 4? Number 4 does not have a b value. It doesn't have a b value. So what does that mean? All that means is the parabola, the vertex of the parabola, does not move right and left. So number 4 actually resembles what we worked on in 8.2. It's when we had an a value and a c value. Now this c value is still our y-intercept. So right here, that's our y-intercept. And so this is going to be the point 0, 4, which means I can already go over here and plot that point right there. Now for this one, because there's no b value, we're not moving right and left. That also serves as my vertex. And if I did negative b over 2a, it would just give me a 0 for the x. So this serves as the y-intercept, but it's also my vertex. Because my a value is negative again, that means it's downward, which makes it what? It makes it a maximum. So now, here's what we are going to do for this one. The vertex is on the axis of symmetry, and the vertex here is also the y-intercept. So there's no partner point for this first point that we plotted right here. But what we can do is make a quick t-chart. And what I'm going to do is I'm going to just do 3 points. So we already know that when x is 0, y is 4. We already found that one. Well, what about when x is negative 1? So what we're going to do here is we're going to do a little calculation like that. Negative 1, I'm just putting in for x. Negative 1 squared is 1 minus 1 plus 3. So it ends up giving me 3 here for this y, and then 3 here for that y. There's your partners. Here's those 2 points. And it's just our normal x squared graph. It's just facing downward. Okay? So you'll have some examples in your homework. Have fun.